All right, so we are doing proportional relationships in lesson 2, and we're doing some practice. Make sure you put your last name and your first name in your class period. These are notes in case you need to refer back to them to read. Just kind of remind yourself of what we're doing and why we're doing it. So we're going to look at this first one. The directions say identify whether each relationship is proportional, and we're going to explain. Now, I know that we've been working basically on unit rate, and what this means is that the proposed relationship is times 1.75. So let's try that out. I'm going to do 2 times 1.75 and see how that works. So using my calculator, 2 times 1.75, it does give me 3.5, so that is a true statement. Let's check it with 4. So my hypothesis is 4 times 1.75. Does that give me the 7? Yes. So that is also proportional relationship of 1.75. I do not know about 8 and 14, so 8 times 1.75 is 14. So yes, this one is proportional. How do I know this? This is a proportional relationship of 1.75 to every pound of bananas. BANANAS. That's awful. I realize that you guys can't see that, so give me just a second. All right, so I think you can read it now. Maybe not. So what it says is this is a proportional relationship of 1.75 to 1 pound of bananas. So hopefully you've got that, and it will help you. This one is the same question. Is this relationship in this table proportional? So it has 2 over 500. So I am going to divide 500 divided by 2 because I'm going to travel this way this time. Since there's no 1 unit rate, do you have to do it this way? No, you don't. You could think about what times 2 gives me 500. But division for me is the simplest of the two. So I'm going to check to see using that calculator. Clear. 500 divided by 2. My answer is 250. So now I got to test the next one by dividing 1,000 by 4. 1,000 divided by 4 equals 250. So that one is true. I'll just put a little check this time instead of reminding. Now let's test the 5 and 1,500. So 1,500 divided by 5 does not. So therefore this is not proportional. So how do I type this answer? Let's see if it will let me show it to you. This is not proportional because the relationship of 250 does not stay constant. That'll be what you type. This is not a proportional relationship because the relationship of 250 does not stay constant. We're going to go to the next one. It's not giving me a table, so I might have to make a table or I have to read to think how I'm going to do it. So before I start doing anything, I'm going to read and kind of underline. Amy worked for 4 hours and made $50. After 6 hours, she made $75 and $125 after 10 hours. Is this a proportional relationship between pay per hour? Okay, so it tells me how to make my table. That would be pay per hour. Now, if I'm thinking which one affects the other, so supposedly the rate or the number of hours is what changes the pay. So if I work 2 hours, it changes and my pay will get higher. So I could have written this either way, but I need to remember this one is pay is dependent upon how many hours I worked, which makes sense. Pay is depending on your hours. So I'm going to fill in some information. I worked 4 hours and I got $50. I worked 6 hours, got $75. I worked 10 hours, got $125. It's a good pay rate. Now I think I'm going to do the same thing. But my brain immediately, because of the way that this looked, and I chose to put it on the table, I want to do 50 divided by 4. But my common sense, that makes sense because I want to know how much I get paid per hour. So let's just try it. If I did 4 divided by 50, that tells me I make 8 cents an hour. So that's supposed to be, reasoning. I'm not going to work for 8 cents an hour. So let's try flipping it the other way and dividing 50 into 4. So 50 divided by 4 is $12.50. So $12.50 an hour for this one. Let's do $75 divided by 6. Still $12.50 an hour. $125 divided by 10. Still $12.50 an hour. So yes, this is proportional. Okay. The answer, it is proportional because, oops, I need a space, because she is paid $12.50, let's put the dollar sign, $12.50 per hour, period. Good job. All right, is the relationship of teachers to students proportional? Not in my classroom. It would be nice. So I'm gonna. It's already given me my table, and I'm gonna make a prediction. I think it's times 10. So let's see if it works. That's awful 10. 2 times 10, yes. Oh, 3 times 10, no. 5 times 10, no. No. So this is not proportional. The constant. Let's not say the constant. Let's say this is not proportional because the constant of 10 does not happen every time. Okay. So let me say that again. This is not proportional because the constant of 10 does not happen every time. It only happens twice. So no, it is not. And I'm grateful for this. Whew. Okay, is the relationship of gas left in the tank to miles different proportion? Tank to miles driven proportional. Well, this does not start. Remember, these are one of the cake problems. Is that at a 0? Nope. I understand that it can go in a 0 and go down. It could be negative, but it's also, look, it's not a straight line. So no, it's not a straight line. This is not a straight line. So not proportional. This is not a straight line, so it is not proportional. Jake charges $15 an hour for swim lessons. The cost is per student. Is the amount of money Jake makes per hour proportional to the number of students who take lessons or to the number of hours? Ooh, that's a good question. So let's do some thinking about this. So for 1 hour and 1 student, Jake gets $15. For 1 hour and 2 students, Jake gets $30. So which one made it change? It wasn't the hours. It was the number of students. So I think we're good. We're going to hit submit, make sure that Miss Began got it right. Six out of 6. We are good to go. Good practice.